For Chapter 7, Lesson 7, we're going to focus in on the area and perimeter of similar figures. We have in our book a couple things to look at. So for the perimeter and area of similar figures, we have two equations to look at. So I want you to look here. For perimeter, it says that to go from figure A to figure B, that the perimeter of B is equal to the perimeter of A multiplied by a scale factor. We need to remember that scale factor is K, and that can be seen over here. Again, in similar figures, the perimeters are related by the scale factor K. The second one we're going to look at is area. And area varies a little different. For area, it says that the area of one similar figure is equal to the area of the other similar figure times the square of the scale factor, which we call K squared. So what's going to be important here is to make sure we're careful about which one we are looking at. We'll take extra care to make sure we are finding the scale factor in order to make this work. Now, I will pre-warn you that when finding the perimeter, there are actually two ways to find it. Only for the perimeter, you could also do this with just finding the proportions from the previous lessons. Now, this only works for perimeter, but this can help make sure you are finding the numbers correctly. Let's look at example 1. Example 1 says two rectangles are similar. One has a length of 6 inches and a perimeter of 24 inches. The other has a length of 7 inches, but what is the perimeter of this rectangle? Now, I find it helpful to always draw some sort of picture to help us understand what's happening with this situation. Now I want to change this a little bit. I realize that the second rectangle might need to be slightly bigger because it's got a larger length. But here's what I know. For the first rectangle, it has a length of 6 inches and a perimeter of 24. We'll call this figure A. The second one we'll call figure B, and we know it has a length of 7, but we do not know the perimeter. So we're going to use the information we have above in your book to help us solve that. Now again, this has two possible ways to do it. One is you could use your understanding of proportions. In fact, let me point that out. One way to do this would be to set up proportions. I'm trying to find the perimeter of B. I could call that X, and it corresponds with the perimeter of A, and it is going to be equal to the scale factor, or in this case, the corresponding parts from each rectangle. Since I started with B, I have to start with B again, which is 7 over 6. This is one way. You know how to finish it. I want to show you the other way of thinking about it. For this case, and as we see above in our book, the perimeter of B is equal to the perimeter of A times a scale factor. Recall that a scale factor is new divided by old. And for this example, B is my new and A is my old. K is 7 divided by 6. And I can go and start filling in the pieces of my equation. The perimeter of B is equal to the perimeter of A is 24 times K, which is 7 over 6. There are plenty of ways you could go about solving this. If you recall, we can turn whole numbers into fractions by putting it over 1. And I know I've shown my students that you can do what's called cross reduction. 24 and 6 can both be divided by 6. So I'm going to go ahead and do that to have smaller numbers. Then I multiply straight across. 4 times 7 is 28 over 1, leaving me with an answer of 28. Had you solved what I did in the first way of doing it, you would have found the same answer. Let us look at an example that is your got it question at the bottom of the page. It says triangle LMN is similar to triangle PQR. If the perimeter of LMN is 64, what is the perimeter of PQR? As we see at the top of the lesson, the perimeter of B, which is my second triangle, in this case, that is the one whose perimeter I do not know. So this B is equal to the perimeter of A times K. K, again, is new divided by old. And for this case, remember, B is always going to be my new one. My new one is going to be the one that I'm trying to find the perimeter or find the area. That is 18 over 24. You can reduce that down by dividing by 6 to find 3 over 4. And now I have my pieces to plug into the equation. All I need is the perimeter of A, which is 64, times my scale factor, which is 3 over 4. I'm going to do the same thing I did before. Turn 64 into a fraction. And I am going to still do my reducing. I do have to check my calculator to make sure I do this right. The 4 and the 64 can both be divided by 4, leaving me with 1 in that denominator, and 64 will become 16. So I need to solve 16 times 3, that's 48, divided by 1, which is equal to 48 meters. So that is the most basic type of question you're going to see. I will remind you, you can solve this as a proportion if you do perimeter over the side is equal to the perimeter over the side of each shape. You could solve that proportion to find the exact same answer. Now let's look at example 2. Example 2 is more of a real world example dealing with blueprints or maps. In a scale drawing, the perimeter of the garden is 64 inches. The actual length of AB is 18 feet. What is the perimeter of the actual garden? Some pieces to remember. When I see something that says scale drawing, that means this is a dilation. Dilation means I'm dealing with similar shapes, which means I can use the rules from the top of the lesson. One key thing to notice here on the side, when I go to find my scale factor, we need to have units that match. So we'll handle that when we get there. Since I'm talking about perimeter, perimeter of B is equal to perimeter of A times K. Now you might ask, what is A and what is B? As a side note, B is going to be the actual garden. A is going to be here in the blueprint. Let's find our scale factor. For our scale factor, new over old, or the side length from B to the side length of A, is 18 feet over 24 inches. Now, we need to have units that match. The units must be the same. So we should ask ourselves whether we should turn this into inches or feet. Since I'm talking about a real life garden, and that is rather large, I would say we want to try to work in feet for this type of problem. So let's convert the 24 inches into feet. We know that there are 12 inches in every foot, so this is equal to 18 feet over 2 feet, which give me an answer of 9 for my scale factor. Now, let's go ahead and see about filling in all these pieces. So, the perimeter for the actual garden is equal to the perimeter of the scale drawing, that's 64, is equal to, I'm sorry, back it up. I should have been saying multiplied by 9. This gives me an answer of, and even I'm going to go and check this on my calculator, 576 feet. Now I'm going to move on to example 3. So hang in there. We're almost through this. Example 3. Example 3 says the Eddingtons have a 5-foot by 8-foot porch on the front of their house. That's this right here. They are building a similar porch on the back with double the dimensions, meaning this chunk back here will be twice as large. Find the area of the back porch. This is a great example because there's more than one possible way of finding it, but I want to use the method we're talking about in this video to help us understand what's happening. When I saw double the dimensions, that meant k is equal to 2. And for this, we're going to say that the front porch is A. And the back porch is B, since that is the one I'm trying to find the area of. And I can find the area of this front porch. Its area is equal to length times width, so 8 times 5. So that's 40. And I have all my pieces now to set up this equation. Now, if we go back to the top of the lesson, it says the area of B is equal to the area of A times K squared. I know what area of A is. That's over here. So this is equal to 40 times, well, K squared is now 2 squared. And I can finish solving this problem. Really be careful. Order of operations comes into play. We have to handle this exponent first. So that's 40 times 4 for 2 squared. And this is equal to 160 feet, since I'm talking about area, squared. We're going to do the got it question that's on the next page of your book. Amalia is painting a mural on her bedroom wall. The image she is reproducing is 48 inches by, I'm sorry, not 48, 4.8 inches by 7.2 inches. If the dimension of the mural is 10 times the dimension of the image, find the area of the mural. So, pieces to know. A is going to be the image, while B is the mural. I also know what K is. K, when it says 10 times, means K is 10. Now we need to find the area of A. And that was given to us when they said 4.8 times, or by, 7.2. Now I'm looking at my calculator to get this. I get 34.56 square inches. And I now have all my pieces to find the area of the mural. the area of the mural is equal to the area of the image times the scale factor squared. I can fill in my pieces. The area of the image is 34.56 times k squared is 10 squared. And now we can follow the order of operations to wrap this up. Exponents first. So 34.56 times 10 squared is 100. So this is equal to 3,456 square inches. Now, I know I went through that answer really fast. Remember, when you're multiplying by 100, all I had was 2 zeros. So I took the decimal place and moved it over 2 spaces, and that's how I got my answer. If you need to, stop the video and go back to any section you need repeated.